So here we are, 3.4, D as in dog, sorry, 4 videos. These sections, these lessons are just so stinking long. All right, this is Descartes' rule of signs. And, you know, we've got this whole stinking list of numbers. Remember in the last one we were using the whole idea of P over Q, and then we'd find all the factors of P, all the factors of Q, and then find all the combination numbers that that we get out of that, and then we try each one of those numbers using synthetic division to find the zeros of the polynomial. And that works pretty good. It takes a long time to go through all of them, sometimes to find them. But Descartes, he came up with an idea that we can at least find out how many positive numbers we have and how many negative numbers we have by looking for a particular pattern. All right. So what we're going to do is we are going to write our polynomial. In fact, we're going to take example 7, and this is just to determine how many positive answers we have and how many negative answers we have. That's all it does. All right, so you may look at it and go, really? I don't really care. But this is part of the lesson, and sometimes it really is helpful because it gives us a clue. Okay, I found all the positive ones, so now I'm just going to try negative ones. All right, so it does give us a little bit of a clue of which numbers to even try with our P over Q. All right, so here's how we do it. Determine the number of variations in sign or of sign in the polynomial function 2x to the 5th, da 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 da. So the way this works is we write our polynomial in descending order, or it could be ascending order, it doesn't really matter, but descending order, 5, 4, 3, 2, 1. We're missing a 4 and a 3 between here, but that's okay, we don't care. This number over here also is important. It cannot be 0. It has to actually be a number, okay, rather than put 0 in there. Okay. Then we determine the number of variations of sign, which means we look at each term and see what the sign is. All right, so here we have a positive, here we have a negative, a positive, and a positive. We're looking for variations of sign, where it switches back and forth. So we go from positive to negative, negative to positive, and then we have positive to positive. Whenever we have a positive to positive, there's no variation, and we ignore that. So all that we're concerned with is when the signs change here and here. So they change twice. So what does that mean? That means the variation of sign is 2. And according to Descartes' rule of signs, bottom of page 296, if we find out that there are 2, as far as the variation of sign is 2, then the number of possible positive answers is either this number or a multiple of 2 less than that. Meaning, subtract 2 from that, and that will give us the other possibility of positive answers. So we can either have 2 positive answers or 0 positive answers. If, for instance, we had 6 variations of sign when we looked at all of this, and we said, oh, it changes sign 6 times, the number of positive answers are going to be 6, 4, 2, or 0. Okay, so it just means that it can be 6, but it can be less than 6 by a positive even integer, which basically is 2. 6, 4, 2, or 0. Those are the possibilities. It can't be 3, it can't be 5, it has to be 6, 4, 2, or 0. What if we had 7 possible answers or variations when we looked up here at the equation? Well, then it would be 5, 3, 1. Those are our possibilities. So if you took whatever number you get, if you subtract 2 from it all the way until you get to 0, then that tells you the possibilities of positive answers that you could get. Okay, so that's positive answers. What do you do as far as negative answers? How do we find out how many negative factors we could have. All right, let's look at that. Let me get rid of all of this, and I'm just going to write this back up here, and then we'll look at and see how to find how many negative numbers we have. All right, negative numbers. What we do for that is we find p of negative x, which means we put a negative in for every x. Okay, and then we rewrite this whole equation, getting our parentheses off. So when we take that to the fifth power, remember, any negative number to an odd exponent is going to give you a negative. So I don't have to solve this. I don't have to go, let's see, negative x times negative x is positive x times negative x is negative. All I do is look at this. If it's odd, then it's going to be, when I take the exponent off, it's going to be negative. So it's going to be negative 2x to the fifth minus 3x squared, because that makes a positive. And then we got negative x plus 4. Now all I'm going to do is look at my variations here. So here to here does not change. Here to here does not change. But here to here does change. So my number of variations for p to the minus x is 1. So I have one variation. So I have a possibility of one negative answer. And again, I have one variation, but remember with the positive, if I had, let's say, 4 answers, then I also subtract by 2, I have those possible number of positive numbers. Same is true with the negatives. I look at this, subtract 2, oh, I end up in the negative side of the number line. So 1 is the only option I have here, because if I subtract 2, I go to negative 1, and you can't have a negative 1 number of answers. So I just have 1 there. All right, so what we're going to do is look at example 8 and kind of get some ideas of what's going on here in a real problem. Okay, so let's look at how many positive answers we could get. And I guess I need to be specific here when I'm talking about possible answers. I'm talking about real answers, okay? The number of real answers, not imaginary numbers or anything like that. So anyway, just to make sure we're on the right page there, we talked about conjugates and all of that earlier, but we'll get into it a little bit more. All right, so what do we have here as far as positive? So positive, real. Let me make a little table here, very similar to the one on page 297. All right, so the total number of zeros that we have is 5. Okay, so positive, and we're going to look and see how many positive answers we could have here. So we look at our change here. We have a positive there, a negative here, a negative here, and a positive here. So we have a variation of sign. 1, it changes sign there. Does not change sign here, but it changes sign there. So possible positive real numbers are 2 and 0. Remember, you subtract 2 from the number, and those are your possible options. Negatives. Let's go ahead and rewrite this. X plus 6. All right, go ahead and rewrite that so that we can see what our variation is going to look like. Because that's a negative 2x to the fifth minus 5x squared plus 3x plus 6. All right, that's the one I want to look at. Does not change sign there. Doesn't change there. The only place it changes sign is right there. So our possible negative real answers is 1. We don't have a choice there. We take 2 away and we get a negative 1, and you can't have a count of negative 1 of anything. Okay, so a possibility of 1 there. And remember, we have 5 answers. So that means that we're only at most looking at a possibility of 3 answers there. Okay? That means there's got to be 2 more answers. Well, those 2 more answers are going to have to be non-real numbers. So those other 2 answers have got to be non-real. All right, what if we have 0 positive numbers? Well, the only number of negative answers we can have is 1. So it doesn't matter if we have 2 positive or 0 positive, we're going to have 1 answer there regardless. So we're going to have 1 answer. So we're looking at combinations here. And if we have 1 answer or 0 answers here, 1 answer here, then we're going to have 4 answers that are non-real, right? So what we're looking at is either this column of the arrangement of answers. All right, so we know we have 5 answers. 2 of them are positive, 1 of them is negative, and 2 of them are non-real. That's one possibility. The other possibility is we don't have any positive ones. We have 1 negative one, and we have 4 non-real numbers. So this is the other possibility of the arrangement of the 5 numbers. All right, so we know we get 5 numbers, but it's kind of nice to know which of those answers are positive, which are negative, and which are non-real numbers. All right, and since we talked about non-real numbers being complex, remember we said they have to occur in pairs because we have conjugates. Okay, so if that's true, we're either going to get 2 or 4. If one of these was an odd number, it wouldn't be this column would have to go away because we couldn't have 3 non-real numbers because they always occur in pairs. So a pair, there's 2, or 2 pairs to give us 4. Okay, so that's all we're looking at. All right, we're not looking at solving it. We're just trying to figure out what possibilities we have of answers, and we have 2 different sets of possibilities there. All right, let's look at example 9. Do the same thing. In fact, we have 2 more examples. They're not really that long or that hard, but I'm running out of time, so I'm just going to make another video.